Now the question is, what is the difference between physics option and chemis option? So a table is given in the NCERT. You can also refer to that table, but here is much detailed solution for this question. Difference between physics option and chemis option. First of all, the force of attractions or the binding force between when the phenomena is physics option. It happens due to van der Waals forces, which are very weak. Chemis option is caused by a chemical bond. So we can easily see that the binding force is greater in chemis option and the bond is stronger in chemis option as compared to physics option. Second, it's not specific in nature and it is reversible in nature. It is highly specific in nature since it requires a chemical bond. So the alignment of the bonds should be in very specific order. That's why it is called that it is highly specific in nature and it is irreversible. So once the chemis option occurs, it is irreversible in nature. Okay, so you can't go back. So you got it. Why I said highly specific? Because suppose we consider two pi bonds. Okay, let me show you with a diagram. Two pi bonds. So this is so the bond overlap will only occur when two pi bonds will be aligned like this only. Okay, lateral overlap or side by side overlap. Okay, so this the overlap will only occur if the alignment is like this. So if the overlap is like this, the overlap will not occur. Okay, so you have to be specific that uh, if you want to have a chemical bond, this direction has to be very specific in nature. Okay. Third, it depends on the nature of gas. More liquefiable gas is adsorbed easily. Third, in Kemi's option point, depend on the nature of gas. Those gases that can react with the adsorbent show Kemi's option. Okay, not all gases react with the adsorbent. Okay, some gases can react, some cannot. So here it will depend on the nature of gas, which has a higher reactivity, and here it will have it will depend on the nature of gas, which is the gas which has more liquefiable quality. It will get absorbed easily. So the enthalpy of adsorption is low around 20 to 40 kilojoule per mole. Enthalpy of adsorption is high around 80 to 240 kilojoule per mole. So energy required for chemisorption is high and energy required for physisorption is quite low. So we can easily compare that low temperature is required and high temperature is required for chemisorption. It is very easy to see why I pointed out this, because for enthalpy, more the temperature required, less the enthalpy, less will be the temperature required. So enthalpy and temperature are quite proportionally related. So after fourth point, fifth point becomes very obvious. It depends on the surface area. Higher the area of surface, higher is the process rate. Sixth point for the chemist option is high activation energy is needed sometimes. Okay. Seventh point is results in multimolecular layers on the adsorbent surface. Seventh is result is unimolecular. Okay.